All right, let's jump right into this explainer. Today, we're unpacking the very real, seriously cool science hidden inside a wildly catchy song about electron microscopy. You know, sometimes the absolute best way to wrap your head around complex physics is actually through art. Or, in this case, a bouncing rhythmic lyric. We're going to use these upbeat lyrics as our literal roadmap into the nanoworld. So, let's get right to it.
Our mission today is laid out perfectly by this opening lyric. Take us in. We're not just looking closely at something. We are going on a journey. We're shrinking down to explore the absolute deepest wonders of the atomic level. This one simple line captures the entire ambition of the microscopy field. We want to go deeper than our eyes could ever possibly take us. But to go that deep, to truly explore the nanoworld, we slam into a massive physical roadblock.
Before we can even think about accessing those atomic wonders, we have to ask a crucial question. Why isn't regular light good enough? I mean, we rely on traditional glass lenses every single day, right? But when you shrink down to the atomic level, the actual physics of visible light literally get in the way. The first verse of our song offers a brilliant, spot-on answer to this exact problem.
The lyrics give it to us totally straight. Zoom past the light, we need something finer. It all comes down to the diffraction limit. See, visible light travels in waves that are roughly 400 to 700 nanometers long. So, if the structure you're trying to look at is smaller than that wavelength, the light just washes right over it. It's kind of like trying to feel the delicate texture of a tiny pebble while wearing giant, thick winter gloves. You just can't resolve the detail. We need something way, way finer.
And that is exactly why we need this tiny wavelengths. By swapping in electrons instead of light, the details literally get brighter and sharper. Since electrons possess mass, their quantum wavelengths are unbelievably tiny. We're talking up to 100,000 times shorter than visible light photons. Crazy, right? Those tiny waves can slip into and actually interact with the absolute smallest structures in the universe, capturing all those fine details that regular light just completely paves over. But swapping out light for electrons creates a whole new set of environmental headaches.
Just listen to the next two lines of the verse. Electrons are flying. Through vacuum they go. Hit the specimen and the secrets show. This perfectly describes the intense physical environment these flying electrons need just to survive their trip from the machine down to the sample. Electrons are incredibly delicate in this context. If you tried to shoot a beam of them through the open air of your standard lab, they'd violently crash into all the oxygen, nitrogen, and carbon dioxide molecules just floating around. They would scatter everywhere, completely failing to reach the specimen.
Which brings us to the vacuum. An ultra-high vacuum is absolutely non-negotiable here. Like we said, shoot that beam through open air and it wouldn't make it a fraction of a millimeter before colliding and scattering uselessly. The vacuum creates a completely empty environment, a clear, mean, free path, so the beam can fly completely uninterrupted. Only then can they actually hit the target. And when they finally hit it, well, that's when the secrets show.
Now, moving into the chorus, the song introduces us to the heavy hitters, the absolute titans of this tech, SEM and TEM. If you spent any time around electron microscopy, these are the two acronyms you see absolutely everywhere. They drive modern nanotechnology. But what do they actually do? How are they fundamentally different? Our songwriter doesn't just drop the acronyms to sound smart. The second verse actually breaks down exactly how these two incredibly powerful tools function.
The lyrics nail the functional differences perfectly. Transmission electron microscopy, or TEM, cuts through thin, like a beam through the night. It transmits straight through an ultra-thin sample to reveal the internal atomic structures. On the flip side, scanning electron microscopy, or SEM, scans the surface and paints it with light. It acts as a topological scanner. It knocks secondary electrons loose to map out the exterior, three-dimensional surface. So, simply put, TEM looks inside, SEM looks outside.
And because of that unbelievably sharp resolution we get from both tools, the song reaches this incredibly triumphant moment. Resolution so sharp we can finally see the nano world dancing right back at me. By zooming past light, utilizing those tiny electron wavelengths, creating that pure vacuum, and wielding our SEM and TEM, the invisible world suddenly, vividly comes to life. But when we finally get that ultra-sharp resolution, what exactly is dancing back at us?
The visual wonders we unlock are just staggering. We literally get to watch individual atoms align in a crystal lattice. We see the microscopic topography of a cellular surface gleam under the SEM scan. We are bringing the fundamental building blocks of reality right into sharp focus. taking totally abstract physics and turning it into tangible, observable science. It proves that bringing science into focus is for sure more than just a dream.
Finally, the outro brings all of this poetic awe crashing back down to the literal, practical reality of a scientist working in the lab. So prep your sample, align that beam. It is such a great reminder that while exploring the nanoworld feels like pure magic, it actually relies on meticulous, highly methodical lab work. The scientist's dream only happens through careful, step-by-step preparation.
So how do we mechanically pull this off? First, you prep your sample. You can't just toss a wet, organic specimen into a high-vacuum chamber. It would instantly vaporize. It has to be meticulously dehydrated, fixed, and often coated in conductive metals. Then, step 2, you perfectly align your electron beam. You focus those electromagnetic lenses to dial in that hidden world. Whether it's the beam cutting through the night into TEM or scanning the surface in an SEM, getting that alignment right is literally everything.
This whole explainer takes us on quite the journey, from realizing regular light just won't cut it, to firing delicate electrons through a pure vacuum, to finally watching atoms align. And it leaves us with this incredible, truly provocative thought. If these tiny, flying electrons can reveal a dancing nanoworld that was completely invisible to us just a century ago, what other unseen secrets of the universe are out there in the dark, just waiting for us to figure out how to align the beam? Thanks so much for joining me, and hey, keep your curiosity focused.